Hi, I'm Chem's best friend and welcome. Please like and subscribe my channel. If you would like to know how to contact me, the information is on the bottom of your screen. So let's learn some chemistry. Today we're going to learn about physical and chemical properties and physical and chemical changes. So before we jump into it, we have to talk about matter. So let's go to my screen. So what is matter? Well, another word is stuff. That's what it is. So when you come home and your parents say, what did you learn in chemistry class? You can say, I learned about stuff. And you are correct. Okay, so matter is anything that has mass and takes up space. If it takes up space, it means it has volume. There is three phases of matter. We have our solid, liquid, and gas. And we can talk a little bit about solid. I want you to notice solids. We have our individual representative particles. The particles are very close together. They are all touching one another. There is a pattern here. So it has a definite shape and has a definite volume. Solids, they are, solids at room temperature, and the little individual particles do not have freedom of movement. They cannot go from here to here. They are kind of stuck in their space. So that's solid. Here we have our liquid. We have a little bit more space between particles. Particles, they're still close together. They still touch one another. But now they can move, slide past one another. So there is a little bit of movement between them. They can move between. So liquids do not have definite shape. However, they do have definite volume. And when we have gases, molecules are far apart. They are not touching one another. They have total freedom of movement. Gases expand to fill their containers. They can also be squeezed. You can squeeze gases. So they have no definite shape and no definite volume. Everything in matter is one or two things. It's either a pure substance or it's a mixture of these pure substances. All right? And pure substances can be two things. It can be compounds or elements. If their composition is always the same, no matter if you take it from nature or make it in a factory, it's a compound. And that perfect example of a compound would be vitamin C. Vitamin C always has the same chemical formula. It doesn't matter if you eat it from a lemon or if you take it from a vitamin C supplement that is made in a factory. Same thing is salt, NaCl. It doesn't matter if you take it from the box or if you take it from the ocean and get rid of all the water and other things and get NaCl from the ocean. If it's a pure substance, it will be the same, always same composition. So compounds, like we can do sugar, C6H12O6, like glucose, water, or it can be elements, which are found on the periodic table of elements. Things can also be a mixture. Let's go to the next slide to talk about mixtures. Mixtures can be one or two things. They can be homogeneous, which is uniform throughout, and heterogeneous, which is different. So remember, mixtures, well, how do you know it's a mixture? Composition varies. Okay, so let's think about this. We have here, let's talk about homogeneous mixtures, which are uniform throughout, all uniform. So here we have gasoline. How do I know gasoline is a mixture? Well, if you go and fill in your car, you have this octane rating. You can have 87 octane, 89, 93. These are different composition of a mixture, how much octane it has. Then it also can have ethanol added to it, so alcohol. But whenever you fill your car with gasoline, the big tank that it's from underground, you can assume that the top of a tank, the gasoline on top, is the same as the gasoline on the bottom. So it's nicely mixed, uniform throughout. Here is another example, coffee. Let's say I put sugar in coffee and I mixed it, dissolved it, and this is also uniform throughout. That means every sip I take will taste the same. Mixtures don't have to be in a liquid state. They can also be in a solid state. So here is stainless steel. Stainless steel is iron and a little bit of carbon. And I know it's a mixture because composition can vary. So we have stainless steel used for cooking, like frying pan, but there's also stainless steel that can be surgical, and they use in hospitals, and that's a little bit different. Little tiny different properties. So here is brass instruments. That's also a nice mixture. You have copper and zinc. Yes, you mix two elements here. It's a mixture. Mixtures also can be in a gas state. So air, put this hot air balloon, the air in this room is a uniform homogeneous mixture, because if I'm standing in this corner, I'm going to have the same amount of oxygen as a person standing in the corner opposite of me. Yes? And then here is tea. I have the same color throughout. I can add lemon, I can mix it, I can add milk, I can mix it, I can add sugar. So this tea right here is all uniform throughout. It's a homogeneous mixture. So now heterogeneous mixture, again, I can vary composition, but this is not uniform throughout. So let's look here. This is iced tea, but look at this. I have ice cubes, I have blueberries. Every sip might be a little different. The sip on the bottom is different than the sip on the top. So that's a heterogeneous mixture. Garden salad. Again, every bite might taste a little bit differently. One bite might have a tomato in it, one bite might not. So it's a heterogeneous mixture. Here we have gravel and water. Gravel is on the bottom. Actually, you have two different phases. Solid gravel and then liquid water on top. So you have different phases. Here we have trail mix. Again, different peanuts. Different other peanuts, and then we have raisins, not uniform throughout. Here we have Italian salad dressing, where we have oil on top and vinegar on the bottom. You actually see different phases. So heterogeneous mixture and soup. It's a great example of a heterogeneous mixture. So how are you doing? You okay with mixtures? The difference between mixtures and pure substances? Okay, so whenever we're going to talk also about matter, you're going to talk about properties of matter. And we're going to talk about different properties that help us distinguish matter. So here, let's use this example. If I give you a piece of metal and I ask you, is this metal magnesium or is this gold? How do you know if I gave you a piece of magnesium? How do you know if I gave you a piece of gold? What would you do? So let's think about this. One of the things we can distinguish magnesium and gold is color, right? And also talk about mass and the volume it takes. So if I talk about the mass of my piece of metal and the volume, well, if I do mass over volume, I'm going to know the density of a metal. I can also see how this metal reacts with oxygen. How does it react? Does it react with oxygen? Does it rust? How does it react with oxygen? Magnesium will rust. Gold will not. Can also talk about how it reacts with acid. Does it react with acid? Its reactivity. Does it react with acid? I can also try to melt it. I can check its melting point. I will probably not be checking the boiling point of metals. I will not be boiling them away. I'll check its melting point. I'll check its density. I can check its specific heat capacity. I can also see if they conduct electricity. Does it conduct Does it conduct electricity? If I gave you iron, you can check if it's magnetic. You can check all these things. Let's keep going. Let's keep going to another example. If I gave you water and gasoline, and I ask you, how do you know if something I gave you is water or gasoline? How do you distinguish? Well, you can look at color, but gasoline, many times it's clear. You can also look at its smell. You can smell it. You can probably test to see if it's flammable. Right? You can probably check it again, its density, right? We can check its flammability. So here's some examples we can use. Okay, so let's think about this. Properties which allow us to distinguish between the two substances without changing the composition of a substance would be physical properties. So which one will we see? Well, color will be a physical property. Density will also be a physical property. I can measure the density of a substance. So this will be density, physical property. Now, a melting point, I can melt gold and then I can solidify it, right? Or melt magnesium, so melting point, physical properties. Heat capacity also, I can measure that. I can measure conduct electricity. I can measure magnetism and smell. However, the other three things, how does it react with oxygen? Well, if I'm going to check if magnesium and gold reacts with oxygen, that would be something would happen and I'm not going to get my substance back. I will actually have to change the composition of a substance. And the same thing is with flammability. So if I'm going to test things, but these are my chemical properties. So chemical properties, if I'm going to test for them, I'm going to get something different and I'm not getting my substance back. So the properties with green dots are my physical properties. I'm going to color code this. And the properties with red dots are my chemical properties. Now also, saying water is not flammable, that's its chemical property. Okay, because you have to still test it, that's its chemical property. Saying gasoline is flammable, that's its chemical property. So usually how something reacts with something, and this is flammable, these are great chemical properties. Okay, so let's go here. So how do you tell the difference between physical and chemical changes? So here is how, really simple. So here we have ice melting. So we have something going from solid to liquid. And then here we have water boiling from liquid to gas. Usually physical changes will be changes of state. So physical changes will be changes of state. Like here is solid going to liquid, going to gas. Look what's happening here. The molecules, see the little representative particle, little Mickey Mouse, water? All these molecules are here. They are holding hands. Here's solid. Now I'm going to see its melting point. I just separated them. I increased the spacing between the molecules here. And here, going to gas, again, things just separated, more spacing between molecules. So physical changes, molecules, your representative molecule stays the same. No changes at all. The substance still stays the same. Just the spacing between the molecules changes. Actually, I forgot to put here, I forgot to quickly mention boiling point. Of course, I can see what's the boiling point. Will be different, and this will be my physical property. There we go. Okay, so physical changes, spacing. Let's go to chemical changes. Here is some example of chemical changes. So we have here is probably copper reacting in nitric acid. And you can see that there's brown gas produced. The liquid becomes blue. Here we have fire, combustion reaction. Here we have, again, a cooking steak. That's a big chemical change. Cooking is chemical change. And here is banana ripening, chemical change. So what's happening in chemical change? So here's a quick example of a combustion reaction. And you can see that if we have methane, there is no methane here. We have something new. If we have here, we have a molecule of oxygen. We don't have it after the reaction. So we got something new. We got a totally new, different substances. So chemical change, you get something new, totally new. Physical change, you separate molecules. You either bring them closer together or separate them further apart. All right? Does this make sense? Okay, so let's put this all together, what we learned. Everything we learned right now. We have matter. Matter can be two things, remember? Can be a mixture or a pure substance. You're going to ask, does it have constant properties and constant composition, no matter where you get it from? The answer is yes, it's a pure substance. If the answer is no, that composition can vary, just like iced tea, you can vary the amount of sugar in it, then it's a mixture. Okay, mixtures can be heterogeneous, that you have very different, not uniform throughout, and homogeneous, uniform throughout. Okay, mixtures can be, this is important, let's make this red. Mixtures can be separated into their pure substances by physical properties. So you can use color. You might use, if you have a mixture of iron, little powder and sulfur powder, you can use magnetism. You can many times use filter. You can use boiling point. If you have a mixture of dissolved salt, you can boil away the water and keep the salt. You can use that property of boiling point. So mixtures can be separated into pure substances using their physical properties. Now, pure substances can be either compounds or elements. And we can separate compounds into their elements by chemical changes. I mean, you can say chemical properties, but we'll have to do a chemical change. Okay? So do you see how this whole ideas about matter fit together into this beautiful flow chart? And you can see where physical change, physical properties fit, and chemical change and chemical properties fit. Yes? All right. So I hope you learned something new. And thank you for watching, and see you next time.